Now what is the first one? Let me write down the formula of the polarization. All the formula that are related with this topic. For example, I equals to I naught cos square theta, and many of the times they relate the intensity with the amplitude. So that formula is I over I naught equals to a square over a naught square, which is just the same thing as writing this one, I1 over I2 equals to a1 square divided by a2 square. If you have intensity 1 at the top, then it should be amplitude 1 at the top, because these two are directly proportional. So the initial amplitude of the wave was how much? 2.6. Let me call it a naught. So a naught is 2.6. The new amplitude needs to be found out. So a needs to be found out. We don't know about the intensity, rather we know the angle of the transmission axis with the polarized light, which is 20 degrees. 20 degrees, only 20 degrees. So I1 over I naught equals to cos square theta. So instead of I1 over I naught, I can write here cos square theta, which is 20 equals to a square divided by a naught square. Make sure when you write it on the calculator, cos 20, don't write it this way. This is incorrect, because you're taking square of the angle and then you're taking the cosine of it. Rather, you should write it this way, cos 20 and square, like this. In this way, the calculator would take the square of the function. Or the other way is, you can find cos 20, press the equals to button, and then do square of the answer. This is the other method. Okay, so cos of 20 would be, and then the square of it would be 0.88. So 0.88. A square is the new amplitude which needs to be found out, divided by a naught. A naught was 2.6. No conversion is needed because all the options are in centimeters. So a square equals to 0.88 times 2.6 square. So whatever your answer is on the right side, you take a square root of it, and the final answer would be 2.4. Alright, for this one, the tricky part is you have a single polarizer filter which was first rotated by the angle 30, and then it was rotated again by the angle further 30. So the new angle of rotation is 60. So what you need to find is, what is the new intensity of the transmitted light? The first time you rotated by the angle 30, the intensity would be I naught cos square of the angle. So 0.75 I naught. Then you rotated it again by the angle further 30. So now the total angle would be 60, and it would be I naught cos square 60. And let me check out this one. What do we get? Cos square 60. I'll take cos 60, close the bracket, then take the square. We get 0.25. Now you need to find the new intensity, the final new intensity, which is this one. You need to find the value of this in terms of, not in terms of I naught. You see, the new intensity is 0.25 times of whatever the original intensity was. but you need to find the value of new intensity in terms of I30, in terms of this one. So you have to do mathematics here. What I can do is I can divide the two equations. So left sides divided by each other, right sides divided by each other. So I60, sorry, I0 cancelled out by I0, I60 over I30 equals to 1 by 3. Now the final new intensity, transmitted intensity, equals to 1 over 3 times I0, which is 0.33 times I0. Sorry, 0.33 times, not I0, 0.33 times I30. So the final new intensity is 0.33 times I30. If the question were what is the final intensity in terms of the original intensity, that would have been 0.25 times of the original. So the easiest way that I explain to solve these questions is using the formula. For example, this is a case when you have one closed end and the other end open. So the formula of the frequency of the nth harmonic is 2n minus 1 times v divided by 4l. If you have both closed ends or both open ends, the formula is nv over 2l. Both open, both closed. Both open or closed. This is the formula for that one. But when one end is open, the other end is closed, we use this formula. Now, which harmonic is this one? For the case when one end is closed and the other end is open, which harmonic is this? This is the second harmonic, because the first harmonic looks something like this. For this case, the first harmonic looks something like this. We have only one node in first harmonic of this case. How many nodes do we have? 2. So this is the second harmonic. So F2 equals to, instead of the value of n, I know this is the second harmonic, so I'll write 2 here. Divided by 4. What is the length in meters? Would be 0.6. What is the speed? 340. So if you hit it on the calculator, you're getting 425, which in 2SF would be 430. Also, if you don't want to memorize the formula, which I strictly recommend that you must memorize the formula, it saves a lot of time. So if you don't want to memorize the formula, you have to use V equals to F lambda, and then you'll have to find the wavelength indirectly from this one. For example, the wavelength, the length here equals to 3/4 of the wavelength, because node to node is lambda by 2, node to the next antinode is lambda by 4, so lambda by 2 plus lambda by 4. So this is 3/4 of the wavelength. And then you can find the value of lambda indirectly. Lambda would be 4 times 0.6 divided by 3. Which is 0.8. So your value of wavelength is 0.8. Then 340 divided by 0.8 would be the frequency. Which is 425. Once again, you can get the same answer. Moving on to the next one. This is a tricky question because in this one you are not provided with any information directly. no value is given in the entire question. So that's why the question looks tricky. So the thing is, initially L is a monochromatic light source with vertical. B is a barrier between waves. Okay, the intensity I at the point on the screen where the center of the bright fringe pattern forms. The center of the bright fringe, you can call it n equals to 0, and from the two slits, the wave would emerge from the two slits. And if the amplitude of the first wave from the first slit is A, the amplitude of the wave from the second slit is also A, which should be identical because we are using a monochromatic light. Then the resultant amplitude, since you have a bright fringe at the center, so the resultant amplitude would be 2A. So this is your first amplitude, 2A. Why 2A? Because at the center we'll be having the bright fringe, because we have the monochromatic light, which is the two sources would be, the light from the two sources would be in phase. Now the situation is when one of the slits is covered, what is the intensity at the same point? So if I cover one of the slit, so we don't even have a slit here. Now you have only a single wave, hence the intensity, hence the amplitude over there would be only A, not 2A, because we have a single wave, and whatever the single wave is, whatever the amplitude of the single wave is, that would be the amplitude on the screen. And now let us call the new intensity as I2 and the initial intensity as I1, and the initial intensity was represented by the symbol I. So let us use a formula. I1 over I2 equals to A1 square over A2 square. What is I1? I. What is I2? We don't know. We need to find I2. What is the intensity at the same point? The new intensity now. You can call it X1. The new intensity is to be found out. A1, what is the initial amplitude? 2A, and the square of that would be 4A square. What is now the new amplitude? Once you have covered a slit, it's only A, so it would be A square. A square would be cancelled out. You need to find the value of X. You can cross multiply. 4X equals to I, and hence X equals to I by 4. Bottom line is, when you cover one of the slit in two slit experiment, if you cover one of the slit, amplitude is reduced to half, intensity is reduced to 1/4. So intensity is reduced to half, and the amplitude is reduced to half, and the intensity is reduced to. And also we have this question in which you are required to find the horizontal force by which a fluid is ejected. For this one, you simply use a formula, F equals to rho A V square. This is density of the fluid. A is a total cross section area. Total cross section, like if you have multiple holes, you gotta multiply that. And V is the speed. So you use this one. For example, density is 900 times what is the cross section area? 400 holes, each one has 0.4 millimeter square. So 400 times 0.4, but we need to convert it into meter square. So it should be 10 to the power minus 6 meter square times the speed is 2.5. And square of it, you'll be getting, I think you'll be getting B as the right answer. I mean, I'm not really sure about the calculation. You can calculate it by yourself. Yeah, just one last question. Here we have this one here, or maybe a couple more. Just a second last, probably. Okay, need to speed up. So the initial wavelength is this one, and first we have third order maximum for the same wavelength and the same position on the string as the second order maximum. We need to find the new wavelength, and it is for the diffraction grating. So the formula that we have, n lambda equals to d sine theta. We have the same diffraction grating, so the value of d would be same, and we have the same what do we call this one, same position, so the angle of the pattern of the maxima, third order maxima and second order maxima, they are saying is same position, means both of them are formed at the same point, so they must be having the same angle. So these two things are same, so you can say n lambda equals to constant, and if these two values are constant, you can also say n1 lambda 1 equals to n2 lambda 2 equals to n3 lambda 3 equals to n4 lambda 4, because the product is constant. Now what is n1? 3. What is lambda 1? 720. What is n2? 2. The second one is the second order. What is now the new wavelength? We don't know. So 3 times 720 divided by 2. 3 times 720 divided by 2. In 2SF we get 1100 nanometer. So this is a very important skill. Okay, don't memorize the question, memorize the skill, learn the skill. If the things are constant, you can, instead of writing all these things in the expression and then cancelling out the things afterwards, you can simply ignore them at the start. And if n lambda is constant, means the product of n and lambda is constant. For example, when we say product of pressure and volume is constant, are we then not able to write this expression P1 V1 equals to P2 V2? Then we can also say P3 V3, but usually we go up till P2 V2. Okay, the last question. For these kind of questions, I suggest the formula. I suggest that students, they must memorize the formula. And the formula that we have for the open ends, NV over 4L. Sorry, NV over 2L. NV over 2L for this one. Both ends open. When one end is open, one end is closed. This is the formula. One end is open, one end is closed. This is the formula. So for first and third, we'll use this formula. For second and fourth, we'll use the different formula, because the case is different. We need to find the lowest frequency. Lowest frequency for all of these cases would be the first harmonic. So the first harmonic, the value of n is 1. V would be there as it is. Speed is same, so you can even ignore the value of V here, because it would be same for all of them. Or you can insert the same value for speed. So 1V, or you can say V over 2. But what is the length here? L represents the length. The length is 2L. So what is the overall expression? V over 4L. Now let's take a look at the second one. For the lowest frequency, the value of N would be 1. 2 minus 1 would be 1. V over 4. Length is 2V. Sorry, 2L. So the final expression for the frequency would be V over 8L. Okay, by the way, this is the expression for the frequency. For the third one, it would be 1 V over 2L, because length in this case is L. For the last one, it would be 2n minus 1 would be 1 V over 4L. So the first harmonic, the frequency of the first harmonic for all of these have now been calculated. For the first one is V over 4L, second one is V over 8L, third one is V over 2L, and the last one is V over 4L. Which one is the lowest? It is V over 8L, because the greatest denominator is for the second option, V over 8L. Whatever the value of V is, whatever the value of L is, but the greatest denominator would be in the option B.